If you take out your highlighter, here's the definition of a trig identity. A trig identity is an equation that has trig functions in it that's always true no matter what angle you decide to use. So we have already learnt some trig identities. Some of the ones that we've already learnt are the reciprocal identities. You know that cosecant is 1 over sine, that secant's 1 over cos, and cotangent is 1 over tan. In fact, we also wrote these the other way, that sine was 1 over cosecant, that cos was 1 over secant, and that tan was 1 over cotangent. So these are equations or statements that are always true no matter what angle you use. We've also learned some quotient identities. One of our big ideas was tan was sine over cos. And another big idea was cotangent was cos over sine. Do you remember another big idea from chapter 6 that would be an identity?
Sorry for interrupting.
So what's another identity that we learned? Yeah. Sine squared plus cos squared, as long as the angle is the same, is always equal to 1. And that's true for any angle. So that's another identity. So what we're going to do is we're going to learn how to do proofs with these identities. In fact, these identities that we have so far are going to be our tools. And they're going to be our tools that we can use to prove new identities. So each of these questions says prove the following. So first of all, when we have a question that says prove, the first thing we're going to do is on our separate piece of paper, we're going to rewrite what it started with. And where the equal sign is, you're going to draw a straight line down. So take out a piece of loose leaf. Rewrite the question because you want to prove that cos of t times secant of t is equal to 1. And what you're allowed to use is you're allowed to use those reciprocal identities, those quotient identities, the identities that you already know are in your toolbox. And you can work on either side. You're just not allowed to move things from one side to the other. And that's why we draw the line. We draw the line to tell ourselves we can work on the left side only, we can work on the right side only, and it's like a puzzle. Can we do things so that the left side and the right side are identical? And often you won't be able to see how to solve the whole question. You just start with something that you know. So you look on both of these sides and say, is there something that I can change? Can I use one of my reciprocal identities? Well, let's go with just changing one of these. What could I change? I could change secant to 1 over cosine, right? So if I do that, and the reason I'm not wanting to just change, I know that for most identities later on, if you know that cos times secant is 1, you can do that directly, and that'll be fine. You want to be careful because they're going to want to see some work. So for one like this, that's the very first one, it's not very good if you just write what the other side was and say, see, I showed it, without showing any work whatsoever. So for this one, I'd want to show a little bit of work. So I can say, well, secant of t is 1 over cos of t. Well, now I have fractions. How do I multiply fractions? I multiply the tops, multiply the bottoms. But you might be able to see here, hey, there's something on the top and the bottom that's the same. These would simplify, and then I'm left with 1. We've solved this puzzle. We've made the left side equal to the right side. That's the goal of all of these puzzles, to try to make the two sides equal. When we're done making them equal, a couple other formatting things. We have to write a statement that we've done what we were asked to. So we write that the left side is equal to the right side. Do you know what these 3 dots mean? Therefore, the left side equals the right side. I like to also, a lot of mathematical proofs end with QED, which is a short form for Latin, quod erat demonstratum, which basically means what was asked for has been demonstrated. So you've shown what you've done. And another thing that is my own little personal touch to proofs is I always like to draw a little square box at the end and make it fancy with shading. You don't have to do that, but if you want to make your own little fancy symbol once you're done your proof, you can. But you do need to say left side equals right side. If you want to add the QED or some other fancy little thing that you've ended your proof, you can. So that's one example. Questions 6 and 7 are really quite easy. Let's just do 8 together. So again, we have sine x secant x equals tan x. Rewrite it, draw your line. And then what could you change? You can change secant to 1 over cos, okay? How do we multiply fractions? Multiply the top, multiply the bottom, so we get. Now you might be tempted to say I'm done right now, but we have to make the sides identical. So either, what's sine x over cos x equal to? You can either write tan x on this side, and then they'd be identical, or you could change this side to sine x over cos x. Either one, so let's say I change this side to sine x over cos x. Another thing that you're going to notice while doing these is every trig function can be changed either to sine or cos or both. Like tan is sine over cos. Cotangent is cos over sine. Secant's 1 over cos. Cosecant's 1 over sine. So one of the strategies that you're going to find you're going to use often is changing things to sine and cos. And now that the left side is identical to the right side, we can write our statement. And finish our proof. Monday is our test. Monday morning, you're asking questions on your review. Okay, I would also like you to have done by Monday on this sheet up to and including number 14.